Greetings! I am Will the Chill, and we are here today for another installment of the Perl Town Hall. Welcome everyone. This is our weekly video live here on Facebook, and our focus is of course on Perl! So welcome to the Perl Town Hall. Again, my name is Will the Chill Braswell, as some of you may know me, and we are here to celebrate our love for Perl and to discuss all kinds of things that are related to Perl. So everybody that tunes in live can type their comments on the screen, which is right over here, according to my view, and I will read them as we go along. And otherwise, we will just have an open discussion. So today, our topic will be dun, 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 dun. It will be the market, the industry, the computer market, the computer industry, our jobs, our things that we do for money. Last week we talked about education and what we do to learn and teach. And so today we're going to talk about what we do for money. Raku for kids. Well, last week we were discussing education. Prairie Nix has said Raku for kids. Okay, Tommy Butler says we need a video conferencing platform. Yes. We tried that out last week. Unfortunately, Facebook Live does not support that at this time. We have free conference call and Zoom, both of which do multiple chats with video, but none of that plugs into Facebook Live. So, sorry, Tommy, but you'll just have to type your comments in like everyone else. So again, today, my name is Will the Chill, and we will be covering industry. We're talking about the computer industry. Last week we covered education. This week we're going to cover the industry. So this is really a lot related to Perl jobs and Perl businesses and companies and so forth. Prairie Nick says an attempt at humor. Yes, I'm sure that it is quite hilarious, and thank you for that. We did talk quite a lot about teenagers and trying to teach Perl to teenagers last week. So if you didn't catch that video, you should be able to scroll back for anyone who was not with us. You can watch it. It was our education video, mostly related to getting teenagers interested in Perl. So again, this week, let's go on about industry. If you want to follow along, you can go to perlcommunity.org, which is right over here, perlcommunity.org. Tommy Butler says, log into Facebook Live from one device and Zoom from another. Okay, well, maybe next week I'll have to set up another laptop for that. But we have one laptop going right now, and that's our max for today. If you want to follow along, please go to perlcommunity.org, and we can go through the industry section. So today we'll again type our comments in for those who would like to talk as we go. So in the past there was seemingly a lot more Perl jobs available. Nowadays, obviously, there are those of us that are still full-time employed in Perl, but we have heard quite a lot of concern about the decline of Perl jobs, and this is true because of Python being one of the big languages of choice. So a lot of the new projects are going into Python, and thus we see a lot of the new jobs are going to Python. So what we want to do to combat against this is obviously to have new projects happening in Perl and to create as many new projects as we can in Perl, especially ones that are pertinent to the current computer industry. So we'll talk about that more here in a minute. So if you're just joining us, please go to perlcommunity.org, and we're going to go through the industry section today. All right, so obviously we have a lot of these grand goals, these very lofty ambitions. Last week we talked about having Perl curriculum taught in every school in the whole world. That's a very large, lofty goal, but we would love to achieve that someday, and even if we don't achieve it, we'll benefit everyone by trying to achieve it. This week, talking about industry, our goal is to have Perl jobs in every company in the world. Again, yes, a very lofty goal, I will admit, but you know, as we said last week, shoot for the moon, and if you miss, you'll land among the stars. So you know, even if we don't get Perl jobs in every single company in the whole world, we will still benefit everyone by trying to do that. And the general idea, of course, would be to promote Perl in every major company at least. Dean, if you can find some free software, go for it. But again, the only ones that I use are Free Conference Call and Zoom, and neither of them has any connection into Facebook Live. So until Facebook Live has another interface, we'll go with this for this week. So let's talk about what kind of things can we do to increase jobs, to create jobs in companies, projects in companies that create jobs, and connecting together candidates with those jobs. So let's start. We are now on perlcommunity.org/industry.html if you're following along. The number one top most important thing that we have right now in the computer industry is what? Machine learning. Yes, that is, I'll go out on a limb, I'll just say that's the most important thing that we've got going in the computer industry right now. So those that can excel in machine learning are getting more money, more pay, more projects, more teams, more company support, more companies getting started, more funding from other companies and governments and customers, and money, money, money. It's all of the money is going towards machine learning, it would seem. So certainly a lot of money is going towards machine learning. So let's talk about machine learning. What does that mean? Well, it's related to artificial intelligence, obviously. The two terms are sometimes used interchangeably. They do not mean exactly the same thing, and even the definitions of each of the two terms is quite debatable. People can argue about what does artificial intelligence mean, and people can equally argue about what does machine learning mean. But let's just say that machine learning is a group of computer software algorithms that enables a computer to perform tasks autonomously. So performing tasks autonomously. In other words, without a human guiding it every step of the way. And this again would be without the need for explicit human instructions. So this should sound, you know, pretty cool and futuristic. Hello, Luis. Good for you to join us. Tommy says artificial intelligence is automated machine learning. Okay, great. So that's a good definition. There are many there are many definitions of machine learning and what is machine learning and what does it mean. So it's up to everyone's interpretation to a certain degree. Yes, the industry wisdom is that artificial intelligence is automated machine learning. we can go with that. It certainly is as good as any definition. What we're seeing right now is that many or even most new commercial software projects do include some machine learning functionality. Even if it's just a tiny little bit somewhere hidden in the back end to optimize a database call or something. I just made that up. But the point is that it doesn't have to be a machine learning project to have machine learning in it somewhere. Lots of projects have machine learning in them, even though they may not actually be machine learning projects, so to speak. They may be in a commercial, in-house software, whatever it may be. Any different kind of software projects could have machine learning embedded in them somewhere. And we are increasingly seeing a lot of machine learning projects, a lot of computer projects that have machine learning as one of the primary components in them. So you know, you're essentially selling your boss on the project by using machine learning buzzwords as your one of your main features, or the main feature in the new project that you want your team to work on inside of your company. Luis says Perl in Code Academy. I'm guessing this is related to last week's talk because we're not talking about Code Academy right now. If I'm mistaken, please let me know, Luis. Otherwise, we will add you to the Perl Teens group later after this video is done. So back to machine learning. Most, or many at least, of the new commercial software projects have some kind of machine learning in them. And I think that it's safe to make some assumptions such as most major corporations have some machine learning code somewhere being used either internally or for their products or whatever. That, you know, it would be impossible to really prove that one way or the other, but it's probably a safe assumption. Let's just take it as an assumption that it's safe to assume that. So then we see the next logical question is, you know, what is the machine learning software that is being used? And there's quite a few different ones. There's popular ones that you've all heard of, probably TensorFlow, Sklearn, also known as Scientific Kit for Learning or scikit-learn, PyTorch, Keras, Pandas, etc. All of these ones that I just mentioned, all of the top machine learning libraries are all Python. Yes, our old nemesis, Python. So this again, as I mentioned a few minutes ago in the introduction, this is something where we see Python is really beating the pants off of Perl. I mean, if there was one thing that we could do to put Perl back on top, it would be to get machine learning going so we can take over machine learning in the corporations. And again, all of this we're talking about today is in relation to the computer industry, to the software market, the computer industry. So Stefan says, currently Python offers to machine learning and AI what Perl did offer approximately 20 years ago for CGI, Common Gateway Interface. Yes, Perl was the big language that helped to build the original interactive websites through the CGI platform, and now Python is doing that for machine learning. Obviously, the internet has evolved past CGI. We've got mostly MVC frameworks and other things like that, Catalyst, Modulicious, and Dancer and Perl. But the analogy stands that yes, Python is now the king because of machine learning, kind of like how Perl used to be the king because of CGI. Dean says Jitsi Meet looks promising. Does it plug in to Facebook Live? That's the question. If it does, that could work. I don't know. So continuing on with Python, what we're looking at right now is all of these so-called greenfield projects. In other words, new projects that are breaking new ground. They're brand new projects in corporations. These are pretty much all using Python, and they're again machine learning features in those software projects somewhere, and those are calling Python libraries. So if you're heavily dependent on Python machine learning libraries, you're probably going to go ahead and just write the whole project in Python. So you have to worry about some weird interlanguage communication issues, and thus you end up hiring Python programmers, and you end up investing in Python and not in Perl. And that's, I think, one of the major things that is, again, contributing to perhaps the continued decline of Perl. It's not the first thing that started it. We won't get into that right now. That's another town hall meeting for another day. But we can see that part of the continued decline of Perl is this whole thing with Python being better because of machine learning. And the greenfield projects, which are now all Python machine learning projects. So we're trying to catch up. We're running, and Python is way off over there in the distance already, way far ahead of us. And we have to catch up. So what are we doing to catch up? Well, that's a very good question. I have started working on ML Perl. This is machine learning Perl. It's the direct competition to all of those ones that I just rattled off a few minutes ago that are all of the Python machine learning libraries. So we started with Sklearn. It's the scikit-learn library, and specifically the k-nearest neighbors algorithm. This is a machine learning algorithm that will take in a bunch of data points and classify those data points as belonging in Class A or Class B, depending on some training data points that you supply, which are already classified as either in the Group A or Group B. And the way that the algorithm works is that it calculates the nearest neighbors. It's called KNN, k-nearest neighbors. So k is any arbitrary integer, usually set to 3 or 5 or some odd numbers, I believe. But basically we calculate the 3 nearest neighbors, for example, and you may apply some weighting to those calculations depending on the algorithms used. And then you figure out which classification is predominant among those 3 nearest neighbors in this example, where k equals 3. If k equals 9, you find the 9 nearest neighbors, and you determine which group is predominant among those. It's a relatively straightforward algorithm, and I've already made a public release of the ML Perl library. It's on CPAN, so you can just type CPAN space ML Perl and hit enter, and it should install on your system. And we're calling this a 0.1 version 0.1 release of ML Perl. So this essentially allows you to run a two-dimensional k-nearest neighbor calculation, and we will add arbitrary dimensional abilities, and we will add sparse data, and we'll add all these other cool features in the future, or hopefully some of y'all will help add those features. But nevertheless, we will have those advanced KNN features added in future releases. For now, it's the basic 2D KNN, and I am very happy to report that using the Perl optimizing compiler, we're able to run Perl at a significantly faster speed than Python. That's right. Take that, Python. It's quite fast and very promising. So I'll read you guys' comments here in just a moment after I finish this little rant about Python and speed. I ran a huge number of speed tests, and what we found was that you have to run for a tremendously long amount of time for Python to try and catch up the speed to Perl. So for any sort of normal execution time, which would put Perl compiled speed being, I think it ran almost up to 40 times faster, 40x. So 4,000%, almost, I think it was just under that, 37 or 38,000% of the speed of Python. And like I said, if you let it run for a long time, then eventually Python will try and catch up in speed. But Perl is definitely quite a bit faster once you get it compiled with Perl. So that's really promising. In fact, I mean, that's one of the most promising aspects of all of this, is that if we get off of our laurels, stop resting on our laurels, as they say, get off of our rear end, and actually start working on Perl, then we can get it to compile and run faster than Python. And that's something we need. We need something to say we're better than Python. We're not just trying to copy them, but we are actually better than Python. Perl is better than Python. So I will pause there and let's see what comments we have here in the sidebar. Prairie Nix says, Perl with tools like Dancer or Modulicious for creating REST APIs is how I tend to keep Perl relevant to the needs of infrastructure at the bank. Prairie works for a major bank working on Perl. The database infrastructure code at the bank is also all done in Perl. These aren't new, but we try to keep everyone up to date with how to do the common tasks with the proper CPAN libraries. This is likely why Perl is still seen as relevant at my company. Okay, great. Well, I'm a big fan of MVC frameworks, and I use Modulicious now on my new projects, and I have used Catalyst a lot for my existing projects. Then Stefan says, I think we need to reinvent the wheel in a really innovative way, analogous CGI again, so that we can be ahead again. I'm not deep in AI, but in my opinion, it is still a young scientific field, so there could be chances to do so. Interesting talk so far. Thank you, Stefan. And yes, I agree that there are ways for Perl to leapfrog over Python, and I think that Stefan is right that machine learning and artificial intelligence is one such way. So if we were to really pull together and everyone work on ML Perl, and try and focus our efforts in a concerted way with a specific goal in mind, not just working on random parts of ML Perl, but coming together and talking to each other and figuring out what's the most important part of ML Perl to work on together, and then everyone focuses on that, that could be a way to blast ahead of Python. And I will go ahead and throw out there a pie in the sky, perhaps controversial, but hopefully positive viewpoint and idea that if we try and work on strong artificial intelligence using Perl, that could really, that would be the thing that would completely put us beyond everyone else. So having a whole bunch of machine learning libraries has made a lot of money for Python lately, but I still don't have an intelligent robot or online companion or AI or a Lieutenant Commander Data written in Python, because there's none. I mean, maybe the military has some hidden away somewhere, but we don't know about that, and that's closed source stuff that we don't care about anyway. We want an open source Perl solution. And so I would go ahead and throw out there strong artificial intelligence, also known as hard AI or true AI, something that is as smart as a person, and would rely on all of these machine learning libraries to accomplish that, because it's probably gonna require all of the different machine learning libraries connected together in some way that we don't even understand right now, in order to accomplish that. So that is what we hope to accomplish with ML Perl, Machine Learning Perl. So let's read a few more comments here. Prairie Nix says, I'll check out ML Perl and see what it's about. Thanks, Prairie. Stefan says, an idea of mine too, that was an idea of mine too, Prairie Nix. The current web frameworks are promising too. Yes, like I said, I have used a lot of Catalyst in the past, and now I'm starting to like Mojolicious, and I'll tell you why. Catalyst requires non-Perl stuff, which is Moose. Dancer requires non-Perl stuff, which is its own domain-specific language. Mojolicious is pure Perl. So it would be easier eventually to compile Mojolicious, and it would be easier to teach Mojolicious to those where we're focusing on a pure Perl solution or approach. So obviously Catalyst and Dancer have a ton of value, and I want to be clear, I'm not in any way against them. I love you, JNAP and MST and everyone else that has contributed to Catalyst, and I still use Catalyst for a lot of important projects like cloudforfree.org. Hi Alex, thank you for joining us, and Benny. Prairie Nix goes on to say something else. Cisco ISE gave us Python examples for the use of their external REST services, and I implement the examples in Perl for distribution to the engineers who use the Cisco ISE. Okay, Tommy says Mojo is the fastest and has WebSockets. Yes, so WebSockets are a big thing, very important, and being the fastest is also critically important. And as I am very focused on speed with the RPerl optimized compiler, as I mentioned, Mojolicious is the shortest path towards us eventually being able to compile web applications. And at that point, that will be a whole other feather in our cap. I mean, it's like the fastest possible web applications, because essentially they're compiling to machine code, and it's ultra fast. Tommy says, I love Catalyst, but that Mojo though. Mojo though. Yes, that's right. Moving along. So, long story short, machine learning, artificial intelligence, this is number one. This is the number one biggest thing that we can do to make money, to receive money, to promote and get sponsors, to get more projects, to have funding inside of our companies and outside of our companies, and every possible thing that's related to the computer industry as far as money is concerned. I think really the number one thing for the foreseeable future is going to be machine learning. So that's why I have personally been working on ML Perl. I've also, of course, been working on R Perl in order to get ML Perl to compile and work super fast. So I've been upgrading the compiler as I go along with ML Perl. So that's enough about machine learning. That's 30 minutes. It deserves more than that, but machine learning, super important, number one. Hi, Jason. Thank you for joining us. Okay, if you're just tuning in, please go to pearlcommunity.org/industry.html. And this is where we're currently just having finished talking about machine learning and how critically important that is. Moving on to science. Yes, science. Well, this is important. Really, it's STEM, software. STEM is not software. STEM is science, technology, engineering, and math. I guess software falls under the technology heading of STEM. But what we're talking about here is building scientific applications, science and math applications in Perl. And so why do we care about science? I'm a scientist. I started writing the Perl compiler so that I could get my scientific code to run really fast. And it does. R Perl is the fastest compiler in the world. It's an open, permanent challenge to anyone who can think that they will be as fast as R Perl, and we will beat you on speed. So that's why I wrote the R Perl compiler. I guess the other reason, which we just covered, is so that we can use Perl to develop artificial intelligence and machine learning. And without the Perl compiler, I am here to tell you, unequivocally, without the Perl compiler, there will be no machine learning in Perl, and there will be no scientific software in Perl. Sure, we can link to some external libraries through CPAN and load in somebody else's Python code or C code and then pretend that it's Perl, but it ain't. It's C, it's Python, it's something that is definitely not Perl. Best case scenario, it's XS code, which for those of you who are not familiar is the bastard stepchild of Perl and C. It's a glue language that allows you to combine together Perl and C, and it's worse than both of the worst parts of both languages combined. It's a terrible solution, and it was the only solution for a long time until R Perl. So now I'm just going to lay down the smackdown that any new science or machine learning software in Perl has to be written in R Perl, or else it's not relevant, because if it's pure Perl but uncompiled, then it's so slow that you might as well be back in the 80s on maybe if something that came before an 8086 computer. If you're trying to call out to some external libraries, then you're not really helping Perl, because again, you're not using Perl code. You're using somebody else's C code or whatever. And while that may be a seemingly viable Band-Aid solution. It's not really the long-term solution that we need to make Perl #1, to put Perl back on top, as we say. Dare I say, to make Perl great again. So, sorry, hopefully no one's offended on either side. It's a totally politically neutral joke. So yes, we need to have scientific software. Why? Because science is critical to global human progress. I mean, this is, without scientific progress, why are we here? Yes, we're here to love our families and so forth, but we should be attempting to achieve scientific progress. Every one of us, certainly that are computer programmers, are contributing hopefully to that in some small way. This is what will ultimately, feed the hungry, clothe the naked, bind up the wounds of the afflicted. All of those things that we're supposed to be doing as good people will be accomplished through science and through super science and supercomputing and the ability to use super fast Perl code, ultra fast Perl code, compiled using our Perl compiler. And it really can, I would argue, change the world. So obviously we'll be using a lot of the machine learning libraries as part of our scientific software. But even if we just forget about the ML stuff right now, the actual scientific simulations themselves need to be built. And what is science software about? It's mostly about simulating scientific principles or physical systems of some kind, whether you're simulating a strain of DNA, or you're simulating the coronavirus, the spread of some disease, or you're simulating a rocket that's going to the Mars or something like that. All of these things are simulations which require massive amounts of computations. This is really one of the main reasons why supercomputers exist, is to perform these types of scientific simulations. And certainly when I worked at the Supercomputer Center at Texas Tech University, this was the main thing that higher educational institutions were running scientific calculations on the supercomputers, and they were simulating this or that theory in order to find the next big breakthrough, to find the next big cure for cancer drug, to find the next type of rocket engine that can carry us to outside of our solar system. Whatever it may be, scientific simulations are the way that we find it. So there is already a very well-known and beloved scientific suite for Perl. Who knows what it is? Raise your hand at home if you already know what it is, or type it in if you're super fast at typing. Oh, okay. Well, before I answer that question, hello! Welcome, my friend. Yes, Mr. Mokapati. You asked if there's any SciPy equivalent in Perl, and as Tommy Butler says, yes, we have ML Perl. This is our new 0.1 release that we have for K-nearest neighbor 2D, and this is something that you can rewind the video when we're done. There will be a lot about that. No, ML Perl is brand new. The MXNet is in no way related to ML Perl. We are completely a pure Perl solution. So ML Perl does not load any external C libraries or Python libraries in any way. All of the code that we write in ML Perl is pure Perl code compiled with our Perl. So you can get the 0.1 ML Perl online already, and again, rewind the video for more information about that. And I will do more talks about ML Perl in the future, but we're doing our first several town hall talks in general terms. So, back to science, weird science, and also totally mundane science. The name, if you haven't guessed it already, the name of the existing Perl software suite that is well known and well beloved by scientists the world over is BioPerl. Yes, BioPerl. And BioPerl is a biology platform in Perl. It's actually a collection of a whole bunch of different tools written in Perl. I'll get back to that in just a moment. Accessible from Perl, which allows data scientists and biologists and the appendant personnel that go along with those industries to quickly and easily slap together some biology-related code. And there's a whole bunch of different libraries that are part of BioPerl. So most biology projects can benefit by using BioPerl because they won't have to reinvent the wheel every time. It will allow them to load up 1, 2, 3, 4, half a dozen different existing BioPerl libraries and piece them all together to create some new software project. So I've talked to 100 different biologists and biotechnology people who use BioPerl. It is still essentially the go-to solution for biology program. It's pretty much the #1 biology software kit, open source development platform as far as I'm aware. I'm not a biologist, but this is my understanding. Please correct me if I'm wrong. So yes, this is a small but significant again, feather in Perl's cap that many people do put forth as an argument as to why Perl is doing okay. Look at BioPerl. There's hundreds of biologists that are doing all these projects with BioPerl. Great. Yes, I love BioPerl. We should all be thankful for BioPerl. But there's a problem with BioPerl, which I'll get to in just a moment because I have another comment to read here. Prairie Nix says PDL, too old, question mark. PDL, the Perl data language, a non-Perl solution to the need for programming fast Perl software in science. And I will respectfully but firmly put forth PDL has been deprecated and replaced by, you guessed it, the RPerl optimizing compiler. So you should never need to write PDL code ever again. If you are, please stop. It's kind of like writing CGI code. I mean, people do still create new CGI projects, but don't. Use Mojolicious instead. People do still create PDL projects, but don't. Please, use RPerl instead. It's old versus new. It's the old, broken, kludgy way and the new, hot, fast way. So, again, I'm not hating on CGI and I'm not hating on PDL. They were critically important for the era in which they existed. For decades, or at least a decade, CGI and PDL were each important in their own time, but not anymore. So please use RPerl, not Perl data language. Okay, so moving on. What is the problem with BioPerl? What is the deal with BioPerl? That's my Seinfeld memory. The problem with BioPerl is that it's not really Perl. It should be called BioC because it's actually mostly C code. And this is the deep, dark, hidden secret about the gemstone of the Perl family, the one of the crown jewels in the Perl family jewels, so to speak. BioPerl is really BioC. It's a wrapper of some really useful Perl code wrapped around the actual biology algorithms, which are all written in C. So I took the time, for those who may not believe me, to make links to the actual source code lines on repositories for all of the main different biology libraries that are hidden behind BioPerl. So you got BLAST, you got FASTA, you got GenScan, you got Emboss, you got ClustalW, and last but not least, T-Coffee. Ding! You can look in the perlcommunity.org website under the software science, the scientific software section, and you will see links to all of those to the actual external API calls, proving that BioPerl is really BioC. So you have to allow for this because this was all before RPerl existed. There was no RPerl compiler when they built BioPerl 15 or 20 years ago, or whenever this first came out. So, all right, fine. BioPerl is really BioC. What are we going to do about that? Well, I'm still conflicted because I hate rewriting good C code. The whole point of RPerl is that it takes Perl code as the input and it generates super optimized C or C++ code as the output. So for production purposes, you don't want to rewrite that code. However, last week we talked about education, and you definitely don't want to try and read that C code for BLAST or FASTA or all of those biology libraries that are written in C. You do not want to read that code. First of all, because it's C and it's tedious and it's all like, manual memory management and bleh, macros and other C libraries and stuff that is super tedious static programming that Perl programmers don't want to care about. Also, most or much of that C code is highly optimized. It's manually optimized code, which means that the algorithms are far from obvious or understandable, and thus that code cannot really be used for educational purposes. I will point out, similarly and importantly, this is a significant important point here, that the Python code for machine learning is also equally what I would respectfully refer to as garbage code. You're never going to be able to read that code and just kind of understand what it does in the way that programmers are, used to doing. This is manually optimized Python code for the things like sklearn and so forth. And yes, they you know, they were perhaps right to do so because they're using an interpreted language and they're trying to make their code run as fast as possible. So sure, go ahead, tweak your code all day and all night and try and make it run a bit faster. I don't do that. I compile my code. Okay, the compiler should be where that optimization occurs. That's how computer science works, guys, in case you didn't know. So we do eventually, as much as it pains me to admit, need to rewrite all of BioPerl. Well, maybe not all of it, because that thin layer of Perl that already exists is usable. We can just tweak it a bit to get it to compile with our Perl, but all of that other code that's all C code has got to get replaced at some point with what I like to refer to as textbook example or you know, textbook ready code examples. This is to say that excuse me, Texas allergies. Yeehaw! The code that we write and that we produce and ship with ML Perl or with BioPerl, whatever, it should be code that is good enough to be taught, copied and pasted into a textbook, and used to teach a course in, for example, biological computer software programming course, or a machine learning algorithms course at a major university. They should be able to copy and paste my ML Perl code and use it to teach the algorithms themselves. The code should be as close to pseudocode as possible. There should be nothing obfuscated about any of the code that we produce, and it should be eminently grokkable. To borrow the Heinleinian terminology, grok just means to understand fully, at least in this usage. So our code in BioPerl should be understandable, and right now it's totally not understandable because it's some external C libraries. Similarly, the Python code for machine learning, it's all manually optimized code. Nobody's going to ever understand that. But you can go look at my KNN code right now in ML Perl. You can copy and paste it straight into a textbook. Go look if you don't believe me. Similarly, I have started working on a bit of scientific code in the past using the RPerl compiler, of course. And so if you check out Physics Perl or Math Perl, you will find that I've started again a beta release of those software suites that has some scientific code and some mathematical code. Some algorithms that I've created and compiled using RPerl, and they are super duper ultra fast. They're faster than anybody else's code. So this is all far, far too much for me to ever accomplish all on my own, obviously. Y'all are going to have to join in and lay down a couple million lines of code like I have over the last few years. So you can check that out. Check out Physics Perl, check out Math Perl, and you'll see all this stuff there. Hi, James Patty, thank you for joining us. And excited to try ML Perl. Okay, awesome, Mr. Mokati. Yes, thank you. Remember that it's still a pre-beta release, version 0.1. But we really are definitely looking forward to moving forward on that project. So, moving on here, a little bit more about scientific programs and applications. Other than BioPerl, there's really no other big, major, important scientific code written in Perl. So that's pretty much the big main one. There's so many different fields of science, but let's just name through a few of them real quick, okay? Because we're going to have to really address all of these, and each one of these is has a mind-blowing complexity to it. Same as BioPerl. So obviously biology is one of them, but you've got logic, numeric mathematics, symbolic algebra, calculus, linear algebra, statistics, physics, chemistry, biology, as I said, geology, astronomy, computer science, social science, medicine, genetics, mechanical engineering, electrical engineering, aerospace engineering, etc., etc., etc. There's, quite a few of the very broad fields of science, and within each of those there are hundreds of potential scientific projects that can be worked on. So basically what we're putting forth here is the same general goal as ML Perl as far as development, that all new science libraries should be written in pure Perl. We should not be calling out to some external C code or Python code or whatever. It should be pure Perl, and we should be using our Perl to compile these new libraries. And I will remind you, in case you weren't aware or had forgotten, our Perl also provides automatic parallelization. So this allows you to have a whole bunch of different parallel things happening all at once, and taking advantage of multi-core processors, clusters, and the cloud, and all of that sort of thing, which is another way to achieve super duper duper speed on these scientific calculations that require more than what a single processor core can handle. So we want to, of course, have, again, the same as machine learning. New projects written in Perl, new jobs written in Perl, new teams put together using Perl, new companies getting started using Perl. All of these things that are going to bring more money to Perl, and more emphasis to show that Perl is really a powerhouse, a powerful tool for scientific progress. And while sometimes scientific progress may go boink, we're hoping that with our Perl and our new Science Perl projects, that scientific progress will go cha-ching. In other words, that we will be able to both help humanity with actual scientific advancements and help the Perl community with more Perl jobs and more scientists that are turning to Perl as their one and only go-to language. Most scientists just choose whatever the easiest language is and stick with it, and they just use that. They're not professional programmers. They don't need to learn a whole bunch of different languages. They just want the one language that works. So let's give them Perl, and let's make it ultra fast, and let's give them a whole bunch of libraries that already work for whatever their field of science may be. So that's a bit about scientific libraries. Here's another comment from Mr. Mokapati. I thought using well-known scientific libraries like LinPack is a smart approach. You seem to say that is not a good idea. What is the rationale? I just talked about that, but I'll cover that again. So if you go to perlcommunity.org/industry.html, you'll see all of my talking points here, and essentially you can see that there's all of these existing libraries like BLAST, FASTA, LinPack, like you mentioned. These are all existing C libraries that have been one way or another connected into Perl. The libraries are not written in Perl. They're mostly written in C or maybe C++ or something like that. Why do we not want to use those? Again, there's the quick and easy approach, which is to just use existing libraries and connect them to Perl and go. This is what BioPerl does. But that will not allow us to teach the next generation of Perl programmers. The only way that we can teach the next generation of Perl programmers is to have good Perl code examples, good sample code to teach them. We've got to have textbooks that are chock full of working, easily understood algorithms written in pure Perl. Pure Perl that can be compiled using our Perl to become super fast. And LinPack or Blast or FastA or all of these external C libraries will not provide that. Their code is manually optimized, not understandable. Some of it's even obfuscated to some degree. Nobody in their right mind is going to be able to easily and quickly open up that code and just understand a whole bunch of complicated scientific algorithms. The scientific principles themselves are difficult enough to understand that it takes a specialist, a biology specialist, a biologist, for example, to understand what do those biology algorithms even do and why. We don't want to belabor the situation even more by forcing them to read someone else's C code when they're not a programmer, understand how complex memory management works, which nobody wants to deal with, even computer programmers. Those things are not going to ever be easily understood, and they're not going to ever be able to be used in a successful classroom environment. So if we're going to build a new curriculum to teach the next generation of programmers, then the code has to be simple, it has to be easy to understand, and it has to be written in pure Perl. So Scikit will not work, LinPack will not work, Blast and FastA and tCoffee and ClustalW will not work. These are all non-Perl code bases, and they are not easily understood code bases. So we've got to write our own pure Perl code. Now, it doesn't mean that we need to go rewriting everything immediately. We can keep the parts that work for now and focus on parts that don't exist at all. But eventually, and I believe I did say eventually a few minutes ago, eventually we will need to rewrite all of BioPerl, rewrite all of LinPack, and so forth, and completely remove those non-C code bases from Perl and from our usage. And once we rewrite all that in our Perl, then we will gain the ability to teach it in classrooms, and we will gain the ultra super speed boost because our Perl is going to be not only faster in serial, but it's going to be auto-parallelizing our code to be arbitrarily faster. Perhaps one might even venture to say infinitely faster, potentially infinitely faster if you have a functionally infinite amount of resources, perhaps on the cloud or something like that. If you have 100,000 CPU cores, you could pretty much parallelize the entire data set at that point and have it all happen in one cycle, for example. And our Perl can do that automatically. So that's why we need to eventually rewrite LinPack. We need to eventually rewrite all of BioPerl's components and so forth. Hopefully that answers your question. If not, then just type again in the comments and let me know, and I'll try and answer more clearly or in a different way. So moving on from science, the next thing we're going to talk about just briefly, because we've already gone over the 1 hour goal or 1 hour target time span, let's just touch on live demos, giving live demos. Who here has given a live demo? Raise your hand. Yes, okay, 1 or 2. I can't see any of you, but it makes us all feel more connected if we pretend. So, live demos. I've given quite a few live demos. I've given hundreds of live demos over the years, including many at conferences. In fact, I pride myself on my ability to work through bugs and to work through internet problems and unforeseen circumstances and always, when I can, try to give a pertinent live software demo during my technical talks. Now, some of the talks don't touch on technical enough subjects to give demos, but most of them do. So I will be eventually incorporating live demos into these Perl Town Hall meetings as soon as we get through all of our general discussions, which will take a couple weeks because there's a lot to discuss. But right now, talking about demos, really this is one of the main things that you can do to show off your work, is to actually get in front of someone and say, look at this thing I made, and hit enter, and it does something really cool. I mean, that's it. That's what software is about, is to, like, you know, make the thing do the thing. It works. It works, as we say in Scouts. So, you know, this is another way that we can connect with human beings. Right now we're connecting online, but generally we would get together face to face, sit down at the same table, or sit down at a conference table or at the desk together, and I'll open up my laptop, I'll load up some website or some terminal or something, I'll hit enter, and away we go. And sometimes I'll even hand over the control to the spectators and let them click on stuff, or maybe it's an interactive demo, or it's a fly through, it's a zoom around, or whatever the case may be. But really your main goal here is to engage them, engage the audience, get them liking what they see, get them to ask you questions about what it's doing. How does it work? Can I change it? Can I tweak it? Can I start it over from the beginning? Can you go back and show me that thing that I missed a second ago? I want to slow it down. I want to speed it up. All of these things, now you've got them. You got them hooked. You got them on the line. You just got to reel them in, keep them going, keep them asking questions, and eventually they're going to be convinced that the thing you're showing them is really cool. And that's what you need. Once they think your Perl code is really cool, they're gonna promote you. They're gonna talk about you to the boss. They're gonna help you get your project started. They're gonna donate to your patreon.com/rperl, I guess. They're going to do all of the things that you need for them to help you with, whatever the case may be. So give them demos, make them clear, make them concise, make the demos customized to your audience. Always think, who is my audience? What would they want to see? If they're a more technical audience, do a deeper dive into the source code. If they're a less technical audience, give them a simple graphical demo or something like that. If it's your boss, give them something that shows how it can save money or speed up some industrial process so that your company can make more money. You've got to think, who is your target audience? Who is going to be actually sitting with me while I run this demo? So, all Perlmonger groups must engage in an ongoing effort to make contact with industry decision makers, to build relationships and curry good favor with those decision makers, to schedule live demos, schedule those demos at a time and location which is convenient to your audience members, and last but not least, give them impressive professional presentations with pertinent Perl projects. I was just wanting to alliterate a whole bunch of P's there at the end. But the point is that go through the whole process. Make contact with them, talk to them, get them interested, set up some times, meet with them, show them your cool stuff. Do not just give them PowerPoint, please. I don't even use PowerPoint on most of my presentations if I can avoid it, because people don't want to see that. Now, sometimes the PowerPoint is important, but minimize it if you can, all right? Make the demo the thing that is the center of attention, not a bunch of slides. And after you give the demo, you got to follow up. You can't just give a demo, see you later, wham, bam, thank you, ma'am. You've got to call them back the next day, or, wait a few days and call them back the next week or whatever. You know your audience best. When do they need you to call them back? What kind of follow-up do they want? Do they want to go out to coffee with you a week later and chat? Do they want a video conference or whatever? But you've got to do a follow-up. And it needs to be like an engaging follow-up, not just, hey, that was cool, thanks for meeting, but ask them questions. Get them to ask you more questions and get them to be more interested again in using your Perl software somehow. And of course, we're trying to create new Perl projects. We're trying to give demos about something so that somebody can take it and get inspired. I'm inspired to create a new Perl project, to bring it back to my company, to bring it back to my community, and do something new with the thing, the Perl thing that was in the demo. So if we can create these new Perl projects, once again, we will create new Perl jobs, we will create new Perl teams, we will create new Perl companies, and we will create new Perl money. And this is about industry, it's about money, it's about jobs. You got to have demos to get people interested. If you're going to build some cool ML Perl thing, you got to give some people some demos. If you're going to build some cool scientific thing, you got to give people some demos. We will be doing online demos of all of these software that I'm talking about in upcoming Perl town hall meetings. So, moving on, we're getting close to the end here, but let's go through real quick a few more here. Perl job fairs. Okay. Usually, job fairs are not specific to Perl. In fact, I've never heard of a Perl-specific job fair outside of a Perl conference or another Perl activity. Which is fine if you're already at that Perl conference, but that rules out most people, because most people, most of the time of the year, are not at a Perl conference. We're at home doing our jobs or in our companies or in our community somewhere. So we need Perl job fairs. And this is a little bit trickier than just giving a demo, because you actually have to connect with companies that need to make Perl hires and that have Perl projects or want to create new Perl projects that has a budget to do so. And as we've been discussing, this is a little bit of a challenge nowadays because of the number of greenfield Perl projects is not as high as we would like it to be. I dare say it's perhaps still declining, and we're trying to turn that curve back upwards again with such things as Science Perl and ML Perl. So I think it's fair to say that in most major metropolitan areas, most big cities in the whole world have at least one company somewhere in that city that has an active Perl project, that has at least one person that's programming Perl or maintaining some Perl thing for that company. And thus there is money being spent on an annual, ongoing basis by that company for that Perl thing. And at some point, their Perl thing will need more maintenance, or their Perl programmer will move away or retire, or they will want to expand that Perl project and make it better, or even create a new Perl project. And whenever any of those things happens, they will need to hire more Perl programmers. So we need to be ready. We need to be prepared to help those companies hire more Perl programmers. That's the thing we need to help do as Perl mongers and Perl enthusiasts and professional Perl developers who don't want to see Perl die because we care about Perl. So obviously we have a lack of viable Perl jobs, and this is what we're trying to address with ML Perl and Science Perl and the rest. But the problem goes both ways. We also have a lack of job applicants. I myself have tried for years to hire qualified Perl programmers to work on R Perl, to work on Cloud for Free, to work on proprietary Perl projects for my customers. And man, oh man, is it hard to find good, qualified, hardworking Perl programmers who are not already hired by some other major corporation. So there is a lack of viable job applicants as well. And this is where it comes again to Perl mongers to take the Perl companies, to take the Perl programmers and job applicants and put them together, okay? These guys need to hire, these guys need to be hired. Put it together, make it happen. So there are some valuable but underutilized resources that already exist for this. There's the jobs.perl.org website. There's the Perl Careers Company. Hi, Peter Sargent. And there's the Perl Jobs on Facebook, which is a group that is successful in helping people find Perl jobs online and to network with one another on Facebook for that purpose. So I would like to extend my thanks to the people that run all of those platforms, because without them, you know, a lot of people, a lot fewer people would have Perl jobs now than they had before. So to everyone who helps run the Perl jobs website and boards and groups, thank you very much. Thank you to Richard Foley and Peter Sargent and all of the other important people that are helping to promote Perl jobs. So we want to build on that. We are actually working already on a Perl website that is a new Perl job fair type website. It has not been released yet, but that will be one of our forthcoming announcements at some point in the hopefully not too distant future. If you'd like to work on that particular website or on any of these other websites or projects, of course, please comment and let me know. And so we need to have a goal, I would say, of at least once a year. Each Perl mongers group in every major city should try to put together a Perl jobs fair. So just call up any groups that use Perl, ask them to have a booth. Even if they're not hiring right now, they can still tell people about their projects and collect resumes for future use. And you know, this is something that's going to require a lot of sort of personal referrals. Hey, I know somebody that has a company, let me call them. Hey, I know somebody who has a friend who needs a job, let me contact them. You're going to have to network with people. You're going to have to talk to human beings. Oh no, I'm a Perl programmer. No. Yes, you know, put on a shirt and tie. Get out there and talk to some people. Impress them with your professionalism. Impress them with the fact that you're interested in the job market and careers and building Perl careers and job fairs. and they'll want to help you. People will like what you're doing, and they'll want to help you with your job fair. Maybe you can get together with a few different ProMonger groups and make a regional job fair. The possibilities are endless. The goal here is to match quality candidates and promising Perl careers, bring it all together, get some more money flowing for Perl projects. So, last but not least, I will mention something that is confusing to a lot of people and is an important point. And this is the status of Perl as a so-called legacy language. So Perl does officially now hold legacy language status, along with just a few other languages, primarily C, C++, and COBOL. I can't remember, Fortran maybe on that list. But long story short, there is actually a whole talk that's linked on the Perl community website by Dr. Thomas Radcliffe. He gave this at the 2016 Perl conference. And it's all about what does it take to become a legacy language and what does it mean to be a legacy language. And I'll give you the very brief overview. A legacy language is a language where there is so much code for that language in the world that it can never be replaced or deleted fully. So I think most of us understand that, C obviously has that status because everything is written in C. Perl is written in C. Windows is written in C, I guess. Linux is written in C. C itself is written in C. C++ is written in C. Everything is written in C. So obviously C is a legacy language. We can never delete that. And now we have found that Perl has achieved legacy language status as well. So this is very difficult to achieve. Obviously only 2 or 3 languages have ever achieved it, and Perl is now on that list, which is should give us a little bit of a relief, sigh of relief, because it means that even if Perl is declining, it can never be totally deleted. And there will always be a need for Perl. The problem is that if we don't do something about the new Perl projects, then there will not be any new Perl projects, any greenfield at some point in the future. And at that point, then the only thing that we will be able to do is to work on the old maintaining of the old legacy code bases. And we don't want to do that. We don't want to be like COBOL is, where that it's all 40-year-old code that no one wants to care about anymore, but you have no choice because it's running some critical back-end infrastructure thing. And so you got to hire a bunch of grumpy old Perl programmers to deal with it. That is not the legacy that I am going to leave. And I don't think it's what you want either. Otherwise, you wouldn't care. You wouldn't be tuned into this program right now. You want to leave a positive legacy, a legacy of new projects, of new growth, of exciting, groundbreaking, dare I say, revolutionary technologies built with Perl. That's the legacy that we want to leave. And so we can take our legacy language status, take this little gold star that's been given to Perl, and we can, again, use it as a feather in our cap and say, look, Perl can never be deleted. You're always going to have us. So you might as well embrace that and start some new greenfield Perl projects with us. Right now, what we find is that all major professional programmers are expected to know a little bit of Perl. And that's the way that companies mitigate their need for Perl programmers at the same time as trying to only hire Python programmers. So they just assume that the Python programmers will also be able to maintain their old Perl code base, And as we now see, those Python programmers are wheedling their way into the whispering in the ears of the middle management who don't know any better to say, let me just port this code from Perl to Python and then delete the old Perl code, and then it's gone. Then they don't have the Perl code at all anymore, and they're purely a Python shop, and we've lost them forever. So go watch the video by Dr. Radcliffe. Be proud of your legacy of Perl, and let's build a new legacy. We'll have a double deuce legacy, okay? Let's have the old legacy code that can never be deleted, and let's have the new awesome machine learning, super science, ultra artificial intelligence legacy that's going to just blow everything else out of the water forever. And that is how we're going to put Perl back on top once again. So that's enough for today. That's our Perl Town Hall meeting for Friday, April 3rd. I thank you all for joining us for our topic of the Perl industry, jobs, and money, especially focused on machine learning, science, and other industry-related Perl topics. Please contact me if you have any other thoughts about this. Hello to everyone who's not live and watching this later, and thank you especially to everyone who tuned in live to give some comments and feedback. I tried to read everyone's comments and take them all into special consideration. So, until next week, this is Will the Chill Braswell signing off and saying, Perl on, everyone. Keep perling. And good night. And